Welcome to LIB Academy, and in this video we are going to continue with calculations under beta functions. And for general definition for beta function is integral from 0 to 1 x to the power n minus 1 into bracket 1 minus x to the power n minus 1 dx equal beta of m n. So we are trying to massage this problem to get a term that will look like this. So generally we are transforming this question to get a term that will look like this so that we can apply the idea of beta functions. So looking at this, we have to get what is in the bracket here to be of the form 1 minus x and not x to the power something. The moment we see something like that, then we have to do some substitution to get rid of those stuff. So let's continue with this question step by step. So in this problem, we have 1 to the 1 minus x to the square root of x. And we know that square root of x is the same as x to the power half. But let's continue. So we have to substitute this by a value. So let u equal square root of x. So now that u equal square root of x, we have to look for the value of x, because at the end of the day, we'll be needing the value of x so that we will substitute it here so that everything will be in terms of u. So we need x, we also need what will correspond to the x. And now we said u equal this. So solving for x, just squaring both sides, we give x to be u squared. So x to be u squared. Now we know the value for x. We also have to solve for dx. So we know the x right here equal to 2 multiplying by u, and the power will decrease by 1, remaining 1. So no need to bring it here, du. This is just like saying this is my x equal u squared. I want to change this with respect to u. So the x here means the x du equal what is changing with respect to u. So 2u power 1, then no need. And now the x, since before I express it in the x straightforward, it means that I can multiply here by 2. If we should do cross multiplication, this will multiply by 1 and this will multiply by that. So giving the x will be 2u du. So that is how come we got this here. So we also need the x. And one thing we also need to do is to check our limit. Yes, because we are doing substitution, we have to check the limit. And we said u equal root of x. So if x equals 0, what will happen to our limit? Because we all know that before we can be able to apply the idea of beta functions, the limit should be 0 to 1. Yes, so we have to check. So if x is 0, we are going to get, then u will be equal to root of 0, which is 0. If x equal 1 here, then our u equal root of 1, which is the same as 1, therefore no problem. So now that we got these values, we can go ahead and do our substitution. So our integral from 0 to 1, x to the power 3. Now we know what corresponds to x. X equal u to the power squared. So we are going to get u to the power u squared all raised to the power 3. So into bracket 1 minus, we said our u to be equal to root of x. So notice that at the end of the day, we are going to get a term like this in the bracket. So that is the main reason, one of the main reasons why we are doing this. And now we also have to replace our dx, and we already solve our dx here. I had to get the x equal 2u right here du. So let's go ahead and group like terms. Integral from 0 to 1, u to the power 2 to the power 3 means u to the power 6. So 2 by 3 6. So u to the power 6. This one we are not going to disturb it. So let's bring 2u here. So 2u here. Then 1 minus u to the power 5 du. Now this is a constant. We can actually bring it out. So 2 integral from 0 to 1. And we have u to the power 1 and u to the power 1 here. Sorry, u to the power 6 and u to the power 1 here. Because they are multiplying, we can actually add the powers. So u to the power 6 plus 1, which is actually 7 du. So this is going to give us 2 u to the power 7, 1 minus u to the power 5 du. So now that we have our term, which looks like this, like the general definition of beta functions, we can go ahead and apply the rule. We know that beta of m equal integral from 0 to 1 x to the power m minus 1, 1 minus x, all to the power n minus 1 dx. So whatever, it means that now what we are going to do is to equate powers, right? To look for our m and n. So we are going to equate powers. So in doing so, our u to the power 7 here should correspond to x to the power m minus 1. So m minus 1 equals 7, right? So negative 1 crossing give us m value to be 8. And n minus 1 here should correspond to what is in the bracket. Like you can actually see the terms. 1 minus s, 1 minus u, so equate their powers. So we have n minus 1 giving us 5. And our n here literally going to be 6. So now we know our beta of mn to give me something like this. So this our beta of m, which is 8, 6, to give us this start here from 0 to 1. This is going to be our beta of 8 to 6. If we evaluate beta of 8, 6, the value that we will get should be the result for this. But we have a constant here, so this constant should affect this. So we should bring our 2 here, right? So our beta of 2 beta 8, 6 should be the solution for this whole expression here. Integral from 0 to 1, x to the power 3, 1 minus root of x to the power 5 dx, right? So now we are simply going to evaluate this, and what we'll get will be the answer for this. And for beta problems, we have two formulas that we can actually apply. We are going to use a relation between beta and gamma. A relation between beta and gamma, beta of beta mn to be gamma m, gamma n, all on gamma m plus n. So let's proceed with this. So this whole thing will give us 2 beta 8, 6 to give us 2 multiplying gamma 8, gamma 6, and gamma 8 plus 6. So, and we know for gamma of positive integers, like if we have gamma of n is going to be, gamma of n minus, so n plus 1, gamma of n plus 1 to give us n factorial. And we also have gamma of n plus 1 equal n gamma n. This formula is used for fractions, and this one is used for terms which are not fractions. So we are going to use this for that. So gamma of 8 means that if we can express 8 in the form 7 plus 1, then it's going to be 7 factorial, right? So gamma of 6, we express it in the form 5 plus 1, which is 6, so giving us 5 factorial. So gamma of 8, we express it in the form 7 plus 1, which is giving us 7 factorial. So we are going to do that here. So 8, we express it in the form of 7 plus 1, which is 8, giving us 7 factorial. 6, we express it in the form of 5 plus 1, which is 6, giving us 5 factorial. All on this whole term will give us 14. So 14, we express in 13 plus 1. So 13 plus 1, and this whole thing will give us 13 factorial. So gamma of 7 will give us 5040. And gamma of 5 give us 120. And gamma of 13 is going to give us 622 800. So simplifying this on your calculator will give our final answer to be 15148. So this is the final solution for this problem.